Alright, okay, so trigonometry. So you talk about it today. It looks at triangles. Now, specifically at the moment, we're going to concentrate on right-angle triangles. Okay? Which other rule have you learned in the past with right-angle triangles?
Is it that right-angle triangles, like their base ones are the same?
Well, I don't know which rule, but I think you're getting confused with isosceles triangles. So which rule have we learned about, Emily? Pythagoras theorem, yes? We all remember that?
Yes.
So that a squared plus b squared is c squared, or whichever way around you want to do it. Yes? So in other words, the two short sides squared and added gives you the long side. Now, in some trigonometry questions, you're actually going to be using Pythagoras as well. How joyful is that? More specifically, though, at the moment we're going to be looking at the connection between one length divided by another, and one of the angles in the triangle, other than the right-hand one. So when I'm talking about in trigonometric terms, if I'm talking about an angle, I'll never be referring to the 90-degree one. Okay, so this trig that we're looking at here is for right-angled triangles. So I know that all my triangles have a right-angled triangle. So when I talk about an angle or the angle, I don't ever mean the right-angle one. Okay? So these, what we're looking at, are trigonometric ratios. So the sides of a right-angled triangle can be labelled according to which angle has been identified. Now, you should know this one here. So the longest side is opposite the right angle and is called the hypotenuse. So the one opposite the right angle is always called the hypotenuse. Then in 99% of the questions, there will only be one other angle marked. Okay, some textbooks unfortunately start labeling both of them and ask you questions about stuff. It makes it very confusing, but the questions that you're going to be doing, there will generally be only one other angle marked. And the lengths of the other two sides will be labelled according to that angle. So if this here is my angle, so if my angle has been labelled here with either a number or a letter, often we use the symbol theta when we're doing trigonometry. If it's opposite that angle, which you can see this green one is, it's called something really complicated. The opposite. Okay, so if it's opposite the angle marked, we call it the opposite side. That's tricky, isn't it? Now, the other one is actually slightly more complicated. So I just slapped it funny now. And it's called the adjacent. Adjacent. Now, if anyone knows, do you know what adjacent is?
Yes.
Next to, yeah. Which makes sense. It's next to the angle. Okay, it's attached to the angle, and it's obviously not the hypotenuse. So when we're labelling our lengths, they can only have one label, either the hypotenuse, or the opposite, or the adjacent. Okay. Now, obviously, when we start labelling stuff, we never normally call it hypotenuse, opposite, adjacent. We just normally use H, O, and A. Now, you need to be able to identify which side we're looking at. So you need to appreciate that depending on how the diagram is drawn and which angle has been marked, you have to have the skill in labelling the lengths accordingly. So given that my right angle for this triangle is here and my right angle for this one is here, I would suggest that you always should label H, then O, then A. Because we know that the hypotenuse is always going to be opposite the right angle. So for this left-hand triangle, I would have H is here. O helps us because we know it's opposite the angle. So if this is here on my left is my angle, then this would be my opposite side. And then the other one has to be the adjacent, whether you knew that or not. For this right-hand triangle, again, labeling H, then O, then A. This big long side here is my hypotenuse. This one here is my opposite. This one here is my adjacent. Now, hopefully you're sitting there thinking, oh my gosh, seriously, she's making such a big deal of this. But if you can't label the lengths correctly, then you're going to get the answers all wrong. Okay? Which is why your next, the next page is practice, where you're just going to label all of these triangles with H-O-A. Okay? So give that back. It is. Alright, okay, so hopefully everybody has all these. Okay? So, hopefully that was a very straightforward, simple, you're thinking, yes, I also like to do trigonometry. Right, so, for every value of theta, so the angle that we're talking about, remember, the angle can change. There is a special value for the ratio of one side divided by the other. Okay, now we could do this big, like, little investigation thing, but we're not going to. The three ratios are called sine, cosine, and tangent. So on your calculators, if you have a baby calc, you'll see a sin, cos, tan button. And on your big calc, you have a button that says trig. And when you press that, you're going to get the trig ratio functions there. So the sine ratio looks at the opposite length divided by the hypotenuse. So the sine of the angle is the opposite length divided by the hypotenuse. The cosine length looks at the adjacent divided by the hypotenuse. And the tangent looks at the opposite divided by adjacent. Now, they no longer give you these formulae. They used to give them to you, but they don't anymore. Okay, so you do need to remember them. Now, there's lots of different ways that people learn how to remember them. Try, and lots of people recognize, if I said so, Sokotoa, you may have heard that before. Now, you may be looking, why on earth is she spelling like that weirdo? Why has she got that small letter up in the air? Well, I've said it's helpful to consider it as these, because remember using the speed, distance, time triangle, yes? So speed is distance over time. So to find the speed, we cover up s and it's distance over time. To find distance, we cover up d and it's speed multiplied by time. The same principle helps with the Sokotoa. So if you imagine that this is secretly a triangle, then the sine of the angle is equal to the opposite divided by the hypotenuse. If you've been given an opposite length and you need to find, if you need to find the opposite length, you could multiply the sine of the angle multiplied by the hypotenuse and so on and so forth. So whilst you don't have to remember it like this, you can just learn them as they are and you can learn to rearrange them. I would suggest that may help, okay? So just by putting the middle letter up in the air is a lot easier when it comes, rather than rearranging, where some people make mistakes.
Wait, so the O's would be on top of.
So this is O on the top, this is A on the top, this is O on the top.
So then it would be on top of the triangle.
Yeah.
So then that's O over T and A.
Yep. Yes.
So just S is O over H, C is A over H, and T is O over H.
That's right.
Cool.
A over H. A over H. Carve, yeah.
And C.
She said cos is A over H. Okay, so add them up here. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Okay, so there are two different situations that you would be having to deal with. Firstly, one of them is that you would be asked to find a missing angle. Okay. So the other is to find a missing length. So we'll focus on the angles first. Now, if we're told the value of the ratio of the sine, cos, or tan, then we're going to need to use a special button on the calculator that looks like these. So sine minus 1, cos minus 1, and tan minus 1. So if you're finding angles, you will be using one of those three buttons. Now, if you're looking at your baby calc, you will see that they're all in yellow on top of the normal sine, cos, and tan. And if you're using your big calc, when you press that trig button, you will see them there as well. So it says sine -1, cos -1, tan -1. Okay? Now, how to use them? Well, if we know that the sine of an angle is equal to 0.5, then we would, to find this angle, it's in a similar way to when we're solving, we undo what's happening on the left, yes? So this sine -1 is we're undoing the sine. Actually, could you pay attention rather than just sketch it, please? Or maybe don't sketch.
Wait, what is this?
Did I miss something?
Yeah.
I apologise.
Yeah, the whole triangle one.
Oh, shush now, I'm sorry. Sorry, so going back to this one, here is my right angle. Sorry, I should put in. So my right angle is here. If I wanted to find the sine of the angle, I have to label my HOA. So that's my first step in any question that we do. So HOA. Now, normally you're not going to have all three labels. Normally you're going to have two. But in this case we have all three. So I know this is H, this is O, this is A. If I want to know the sine of the angle, I know that that's opposite over hypotenuse. So what's my opposite length here? 5.
No.
And what's my hypotenuse? 30. So my sine of my angle would be equal to 5 over 30. The cos of the angle, so cos is car. So that's A, which is 12, and H, which is 13. And then tan is TOA, so that's 5 over 12. Okay, so hopefully you appreciate that if you've labelled them the wrong way around, this gets all messed up. Now, as a little additional information for you here, these two are slightly more restricting than the tan. Because for a sine of something and a cos of something, these values here cannot be greater than 1. Okay? So if you had labelled them incorrectly, and you had for some reason 12 over 5, 12 over 5 is more than 1, which means that you've done something wrong. So when it's sine and cos, these values here cannot be greater than 1. Okay? They are able to be negative, so you can have negative values. Don't think you'll meet any negative ones, but you can have negative values. But you can't have them greater than 1. Okay? The tan can be whatever you like. So that's an important thing. Apologies, thank you for that. Alright, so going into finding the angles, as I said, if we know that the sine of an angle is 0.5, well, we need to find that angle. So we undo the sine process, so we would type into our calculators sine -1 is 0.5. Now, if you have this value here, instead of 0.5, if you had it as a fraction, like we did just now, we had a fraction, you can just input them as a fraction. So you don't have to change it to the decimal. So what do we get if we type into our calcs sine -1 is 0.5? 30. Now, those of you that are doing it on your calcs, you will get 30. Some of you may not. And there's a reason why you may not. What do you get?
0.5.
Okay, so Natanya has her calculator in a different mode. Now, up until this point, it hasn't really mattered about your calculator mode. But at the top of it, the majority of your, especially baby calcs, will be in degree mode. So you would see a D at the top. So if you're when you're going into your GCSE exam, we will be reminding you to make sure your calculator is in the correct mode. So it needs to have a D at the top, not an R or a G. Okay? I can show you how to change it if you're not sure. Now, your big calcs, unfortunately, they default to being in radians, which is the R. So we need to make sure it goes back to being in degree. You use your big cap or the little one?
Yeah.
Big cap. All right, so let's pause. All right, so you need to hit, I think it's document, yeah. So hit document to get this option, these options. Do you get see that? Oh, you're still turning on. So document, it's in red, look on the screen.
It's just dark.
It's doc, yeah. All right, same meat, different gravy.
Okay.
So it's in red, look. That's why we're doing it on the screen so you can see. Now, we're going to settings, bless you, which is number 7 on mine.
Yeah.
Okay, and we're going to document settings. So settings, document settings. Now, I think we looked at this bit already, didn't we? The float bit. Tanya, why are you looking at me like that? You're still not on? Okay, now have we changed this float thing or not? Does yours still say float 6?
Yeah.
Okay, now what this does, it limits how many digits you can actually see on your screen. Now some questions, and they don't come up that often, but they may do, say things like calculate this and write all the digits on your calculator screen. So if you've only got float 6, then it's only going to give you 6 digits and you're not going to get full marks for it. So can you actually change that to be float 12?
What's fix?
Fix, I think some other mode, I don't know.
Okay.
But I'm just sticking with float 12. Okay? Now, yours probably now here says radian. Yes? So can you change it to be degree? And then everything else you should be able to keep as it is. Now, what I want you to do is though make this default. So if you hit make default, and then you press OK, it means that every time you turn on your calculator, you don't have to go through this process. It will already be in degrees. Now, the only times that it does change is if you have to reset it for whatever reason. Okay? Right, okay. So, at GCSE level, you're just saying in degrees. So you will need to always make sure that you're in degree mode. If you ever do something like this, and you get an answer that's a fraction or a small number, essentially it would be less than 7, it means that you're in the wrong mode. Okay, so look to see if your answer might be sense. Now, tan theta equals 1. How are we going to find theta? What do you think we're going to do? Theta would equal what? Tan to the minus 1 of 1. Okay, so we're undoing the sine or the tan or the cos. 45. 45, lovely. Now, these are obviously both degrees because we just talked about that being a degree mode. Yes, that's fine. All right, so if we're finding angles, you're always going to be using this is called the inverse sine, cos, tan button. Okay, so let's have a look at a kind of example you might have. So steps to follow. Label your side lengths, H or A. Identify which ratio you're going to be using. Now, you'll only be using one of the ratios. You would only be able to use one of them. So that's what some people say. How do I know? Is it sine? Is it cos? Is it tan? What's the deal? It will depend on each question as to which information they've given you and what they've asked you to find. Okay? You're then going to write the appropriate ratio statement, and then you're going to use the inverse button to find the angle. So that's how we're going to do each of these. So, first example, here's our diagram. I'm going to label H, O, A. H, O, A. Now for these questions, it's a lot easier to answer my next question to you. Which of my HOA is irrelevant here? Which is the one that I'm not using? A. Okay. So what I'm going to do is I'm going to cross that out.
Why are you not using A?
Because it's got no dates on it. Yeah. And it's this reason that I don't like questions or textbooks that start labeling everything, because it starts confusing the whole process, because in an exam question you wouldn't have labels on everything. So here it's clear we've got labels on the O and the H side, we've got nothing on the A, so that's not helping us at all. So looking that we've got an O and an H, which do you think of the three ratios of SO, CAR and TOA that we're going to be using for this question, Jodie? Exactly. So I'm going to write these here, just so we can refer to them, because we can't on a different page. So we've got SO, CAR, TOA. We've got O and H, which is obviously this one here. Okay? So we write so. We can now write, as I said, our appropriate statement. So means the sine of the angle. Now, they've labelled their angle theta, so that's where I'm going to have my theta. So sine of theta is equal to, we cover up the S, we've got O over H. So sine of theta is O over H. Oh, silly things I'm trying to talk about. So sine of theta is equal to which values? 5 over 11. Is this okay? We follow it?
Yes.
Yeah? What am I going to do now to find theta? Sine minus 1 bracket 5 over 11. As I said, you can put it in as a fraction, you can put it in as divide, you can put it in however you wish.
27.035.
27.035. So I would put 0. So normally we would do 3 significant figures or 1 decimal place. Now, some people are like, well, that's the same as 27. Well, the fact that we put 0.0 shows that we've rounded it, and it's not exactly 27. Okay, so 27.0 is different.
So you always round it to 3SF.
3SF or 1 dp.
I put mine in the calculator and so syntax error.
Let me just put it. Okay, so the other example, same steps. Label HOA. Which of these lengths, Ashley Stevens, which of these lengths is no use to me in this one?
H.
H, lovely. Which means, Cassidy, which of the 3 SOCAR TOA am I going to use for this question? Nice. So I'm going to write TOA here, because it's O and A. Okay? We need to remember that TOA, now, the reason that we're covering up the big S or the T or the C is because we are finding the angle. Now, the angle always belongs with the sine, the cos, or the tan. You can't ever type into your calculator a sine and leave it. It's always got to be sine of something. Okay? A number, yeah. So, and that number will always be the value of the angle. So if we're trying to find the angle, that's why we're writing, that's why we would cover up the T. So we would say tan theta is O over A. So theta would, oh no, let's write the numbers in this H. So tan theta would be 8 over 6. And so theta would be tan to the minus 1 of 8 over 6. And yes, 8 over 6 can be simplified, but we don't need to simplify anything, we can just treat it up as is. Yeah.
Would you have to go through all those like first 3 steps, or can you just?
No, so bare minimum that I would expect to see is this one and this one. That's your call. Well, they may. Okay. So we happy with that? 53.1 is what I was told. Yes. So here's some examples. So I'll leave you to have a go at them, and then we'll come back and make sure we've all got the right thing. So remember, labeling HOA, decide which length we haven't got, decide which ratio it's going to be, make your statement, and then find your angle. So in these ones, obviously, it's not theta, it's x. So you'd be having sine x, cos x, or tan x. Okay.
Wow.
Alright, okay, so hopefully have you all done those? Yes?
Yeah.
What values did we get? So I'm sorry. Oh, would you like me to pause? So, like Groundhog Day, we're back to it. What are my actual values? I obviously can't work this out in my head.
I think 27, 45, 46, 45,
43.
45.6 and
60.3.
Alright, just the end. Lots of people say the same numbers. Good option. So we've got 20 minutes. Do you want to practice this or should I just finish off the task?
No, practice.
Finish.
Actually, I shouldn't have asked because now I'm going to do what I want to do anyway. So I'm going to let you practice.
Yay!
Because